to deploy an application into an OpenStack cloud. So what does Solum do? It converts code into a managed application running in an OpenStack cloud at the push of a button. So the focus here is on ease of use, making developers' life easier, and taking it from code into a deployed application really quickly and easily without them having to set up extra tools. So what is the usual workflow in going from, for instance, GitHub repo to a running application in the cloud? So you usually have some kind of unit testing, you build, packaging, distribution, and that's all in your universe, your application universe. And then provisioning, configuring, deployment, and scaling is all in the sort of operational area. And these are all steps that you would normally have to either do manually or set up yourself to automate. And Solum aims to streamline that whole process. So basically, you don't have to do it. So at the moment, what we're doing is we're using a StackForge project called Mistral, which is workflow as a service to automate the running of the tasks. And so one of those can be unit tests, and then building images, which can be either Docker images or VM images, and deployment using the Heat project. So I don't know if you're familiar, the Heat project is used to deploy using a template. So you define a template with servers, networking, volumes, etc. And you say, this is the specification for my app. Go deploy it, and we'll do that. And so basically, as inputs, when it keeps updating, you'll just be changing the image ID usually, and it'll be updating your application. So steps to set up a Solum pipeline. So the pipeline is basically that process of going from your code to a deployment. So you have a GitHub repo, for instance. You create what we call a plan file, which basically has the URL to that, any dependencies, and it also basically tells Solum the format inside that Git repo. And you go and register that with Solum, and you create a pipeline. And from that, when you say create, it basically will deploy it. And then every time you git push, you put a trigger in GitHub's configuration, and every time you push to your repo, it'll trigger the pipeline to go and run through. So currently we're using the Heroku format, but we want to support other formats as well. In fact, I think we've got patches up for Docker, just native Docker format as well. So Heroku is nothing special really, it just detects based on the language, so it looks for Python-y things, or Ruby, or Java, etc. The only special thing is Foreman, which is a little file that it's called proc file, which says how to start your application. Other than that, it's basically just as you would naturally for the language that you're writing in. So what does a plan file look like? This is basically comes from the camp specification, so I don't think this will last that long. It'll probably be reworked a little bit to be simpler and to have some other features, but the main thing here is the actual Git URL. The artifact type, it says, is Heroku. That can be Docker, and it can be some other things. And the language pack, that's basically the base image that you want to use. So when you go to customize your image, what are you basing the image on? And you can basically specify custom images from Glance. You go and register your app, and you notice the okay, that's just registering the app. The next one is creating a pipeline that has a trigger URL. That's the URL that you would go and put into GitHub. And so whenever you do a push, it would trigger back to Solum to say, hey, you need to start the pipeline. The highlighted bit there, the build deploy, that is basically the name of a Mistral workbook, which is a workflow that defines the steps that you want to take in your pipeline. So if you have unit testing, builds, functional tests, and then finally deployment, what all those can be. So what does a Mistral workflow look like? Let's see if we can get this. So here is, so this is a native Mistral workflow. So it's got a start, it creates the image, Salkeld source URL, the name that you want the image called, source URL, and it'll publish these entities here. So these are inputs at the top, the parameters, and publishing, and on success. And there's also an on failure. I haven't got it here, but basically that says what to do next depending on the results of the previous step. And here's like a wait for image. So you'll kick off an image build, and it won't be completed straight away. You need to check back, and it'll poll depending on these retry settings. And when it's done, it'll move on to the next stage. In this case is deploy, and that's just basically a heat stack update. And then it'll wait and make sure that it's all completed correctly as well. Come on. Sorry about that. Skip through. Okay, so we've been through that. Plan, okay. So I've just made basically a walkthrough of what this process will look like. And I'll just try and talk through that. So basically, this is only going to do an image build, and the reason for that is recently Docker's changed to not require a local registry, and basically I haven't got my Vagrant set up. So it's just a bit different, and Nova Docker wasn't working for me. But this should basically show you what it would look like. So I've just made a little script, and all it's going to do is do a app create and a pipeline create. And this is a little plan file I'm giving it, just with an example a Python project. And this is my status. Basically, I run that, and it'll tell me what's happening. So we are busy building a Horizon UI. It's just a bit rough at the moment, so it's as easy to show that. So there we go and create it. So it creates a plan and the pipeline. And it's also just, when we create the pipeline, we also create a heat stack, which is totally empty. And that's just because some issues with trust, but it's just a workaround. So this is just showing we've got nothing there related to that application yet. We use the command line actually from a script. We don't do it in, so I can tell you in depth a bit later. So you can see there's two tasks here, start and a wait for image. The start is succeeded, and it says delayed there, meaning it's gone through at least once and checked to see what the status is, and it's still pending. So you can see Docker running in the background there. And at this point, it's just waiting for the Docker build to create. Still delayed. This is just going over to showing you it's got Mistral running, heat, and the Solum daemons. It's a really lovely output, isn't it? No, Mistral. Yeah, it probably didn't think that we would put the whole template as a parameter. So. And we go back. All right, let's check once more. Okay, so they're both done. It's done the image, and that's all run through. So you can now go and check in Docker, and there's the example Python at the top. So it's built that. And then I'll also run through the git push stage. So I'll go further up and get that webhook and just show you that kicking that off also works. There you go, the trigger URL. Let's copy that in 2 chunks. So this is basically using a magic UUID, and it goes and looks up a trust ID within Solum and kicks off the heat update using that. So we could use EC2 sign key pair, but URL, sorry, but just go on for that for the moment. So you can see there's 2 executions now. One's running, and the previous one that's succeeded. So that's one of the nice things about Mistral, is it obviously keeps all the executions that you've got that's run through, and you can go and look at the history of all your runs and dig into them further. And basically, Solum doesn't have to do that at all. And so there's 2 sets here. That one there is still waiting for the last build. So it is actually finished. You see the none, the way Docker shows it, it's one built on top of the other one. It's just Mistral has to go and check it, and then we'll put it as success. One more. So from a user point of view, I wouldn't expect long-term anyone to be really using a command line much, and this to look more like, say, a Jenkins UI page, list of green and red buttons, red lights to see how you're doing. It's just a bit of an early stage. So there you go, the images were built from a git push. Through this. Right, so where does Solum fit into the current OpenStack? So you can see here we're using Heat, Glance, Nova. That's basically Heat, utilizing all of that. We use Glance directly to insert the image into Glance. So Solum basically interacts directly with Mistral, and it passes in the inputs and fires it off and pretty much forgets it at that point. It only stores the execution UUID, and from that point on, Mistral takes care of anything, and we can then go and query it later for any other information. Mistral has an idea of plugins, so we have a heat update plugin and an image building plugin, and those are instantiated when you specify that task type. Why use Mistral for the workflow? It keeps track of the workflow and states as you would expect any workflow to do. It also defines a DSL, so we don't have to invent a new one. And we would have to, because basically we want users to be able to customize the workflow. So if you want to provide that, then you're going to have to come up with something or reuse. So we decided to reuse Mistral, partly because it's got a DSL already. The other nice thing about it is you don't have to write a server to run the, if you're using a library like TaskFlow, you have to actually sit there and drive it. Whereas this, it's just go, and it does the whole thing itself. It keeps the execution history, which is very nice, so we don't have to basically store all that stuff. And we can write plugins, which is also quite neat, and is quite extensible from a functional point of view. Yep?
Where is Mistral on the information integration?
I don't think they haven't applied, so basically it's still early stages. I think they would like to at some point, but want to get real as far as stability goes, and would like to really know that API and everything is super stable. So they're maintaining stability mainly for our purposes and for a couple of other people that are using it. but they are actively working, developing on newer ways of doing things as well. So I think one of the things from our point of view is we'd like to use them. It's like really using someone using their project in anger, as it were, and to iron out any issues. We have had to contribute to Mistral to bring our use cases to them, and I think that makes both projects stronger, basically. Why use Heat to deploy? So we could drive Nova API directly, but we can't assume a single VM. It allows us to do autoscaling. It allows a user to provide a template and so do all sorts of interesting things. And so it allows more complexity. We only need to look at updating the template. We don't have to worry about the intricacies of all the different client libraries. Another option, people are interested potentially in integrating with Murano. That's another option, and I think it won't be particularly difficult to do either. All of this, I think, makes Solum simple and powerful by making most use as possibly can with other projects. If you try and redo implementation, you'll end up spending a lot of time unnecessarily. We'd like to rather contribute to the other projects, and if they're a little bit lacking, we'll add to them rather than redoing stuff. I think that's one of the values as far as an operator. If you're already managing OpenStack and adding Solum to the mix is a relatively small step compared to having a big Cloud Foundry, which is quite a large code base that doesn't assume much about the underlying infrastructure. Some future ideas are customizable infrastructure, so you can provide your own build farm, for instance. And so the way that would work is basically you provide a template of what you want your infrastructure to look like. We started and basically just once that heat stack is created, get the outputs and pass that into the matching Mistral plugin. So you could essentially just return a URL to a Jenkins server with the username, password, etc., and drive things that way. We're busy with Horizon UI and service framework. That's the next thing to do. It's basically to be able to plug in arbitrary other services as dependencies to your application. So for instance, like Trove. And there's been some interest in integration with Murano as well. So how does Solum compare to Heroku Cloud Foundry? So the other PaaSes are mostly deployments focused and less on the path on getting there. Solum is aiming at trying to improve the developer's usability of OpenStack. So by making it an easy path to say, here's my code base, I don't want to have to set up Jenkins and a whole pipeline and all that stuff. And all of those resources are within the same cloud as well. So it's like basically a one-stop shop. I don't have to hassle with a lot of infrastructure. Any questions? So I've got some example